Hello everyone, this is Zach, and I'm doing a C++ tutorial on the Hex puzzle. This is my solution that the user will then need to recreate once they start the game and move all the game pieces to match as you see here. To see how I did that, let's go down to the code. Alright, so here we are in my source file, and under int main all I have is a pointer that points to a display function which will just display everything to the screen. And in my header file here, I have all my private and my public classes, display being one of the public classes. Here is my hex array, and it holds all of the game pieces, 7 game pieces, as well as their 6 sides. And before I show you the bulk of my code, I want to show you a picture that helps me kind of keep track of which array needed to match up with which other array. Alright, so here we have my picture that I've made, and each of the white numbers corresponds with the hex number, so that would be that first number of the array. So hex 00 would correspond with this side right here, and hex 13 would correspond with this side here. So I would need to make sure 13 matches with 00, and so on. So now that we've gotten which pieces or which parts of the array need to match up with which other parts of the array, and we can look back at that whenever we need. Let's go to the puzzle.cpp file. I have my libraries included, and in our puzzle function, this is going to be the bulk of our program. I randomly generate a number that will help us shuffle randomly each of the different game pieces, and then I'll populate the hex by using a nested for loop to run through each game piece and give it a number for each of the different I indexes. So 00 will get a 1, 02 will get a 2, and so on for each of the different game pieces. After I populate the hex, I'm going to go to this do while loop that will run until the check that says whether or not all of the different game pieces match up with each other. The first loop that we're going to do is a shuffle loop, and so all we're going to do is we're going to send X, so each different game piece, into the shuffle function, and I'm going to randomly shuffle that whole array. So 00 will be shuffled, all of the different sides will be shuffled with each other, and each different game piece will have a random set of numbers in all of its indexes. After I've shuffled them, I'm going to check the hex side. Under this function, I have a lot of logic built in, and I'm going to explain that in just a moment. Okay, so here's check hex side. I have a for loop that runs from 0 to 3, and I will run a center check and then a front check, and then when I is equal to 2, I'll run a center check again, and then I'll run a back check to make sure that each of the sides match each other. So the second for loop is going to be incrementing from 1 to 6, and so it'll check all of the game pieces around the outside against one another. So for x equal to 1, we're going to send that value to switch hex. In switch hex, we receive 4 values. We receive our game piece that we're currently checking. We're going to receive the direction that we're going to be checking, as well as the face of the game piece we're using and the game piece that we're checking against. So for our center check, and it will also correspond with the front and back check, we are sending a 1, and then we're going to send the opposite of 1, because the opposite of 1 is 0, or the opposite of 2 is 0, opposite of 3, so that we can check all of our numbers against 0 without having to copy and paste any code. We're going to send a 2, because what we're going to do is we're going to add a 2 to the game piece value to get our side of the game piece, because each one is 2 higher than its game piece number. 3 plus 2 is 5, 4 plus 2 is 6, and so what we do there is we mod all of those numbers before we do any of the checks to make sure that even if they go over the size of the array, it will start over at 0 and 1 and 2, because even 6 plus 2 is 8, and so we can't have 8 if we only have 6 sides. So that 2 corresponds with our side of the game piece that we're currently on. That hex face is receiving a -1 because the number that corresponds with this game piece is the 0. So our 1, 3 needs to match the 0, 0, or our 2, 4 needs to match our 0, 1. And all it is receiving is a -1, which is 1 less than the game piece. 0 is less than 1. 2 is 1 less than, 1 greater than 1, you know, so that -1 is just the 0's side that needs to be checking against. So what we do is, in this for loop, we have this I, which is going to correspond with each side of each game piece. So for this whole loop, we're just checking game piece 1. And so for game piece 1, side 0, we're going to say, is game piece 1 side 0 equal to 0, 0? Well, if it is, we need to switch that, and so what we'll do is we'll put the side that we need to match up with the 0, 0, which is 1, 3, and we will put it in a temp. And then we will put the value that was in that 1, 0, we'll put it into the number that should be matching 0, 0, and then we'll put that temp back into the number we were just on, which is 1, 0. And so what we've essentially done is we've switched that 1, 0 with the 1, 3 to get that matching number into the 3. Even if the number that we're on is 1, 3 and it matches, all it's going to do is it's going to switch with itself. So we don't have to worry about if it already matches, it's just going to trade itself for the same number and we're fine. But if it's not, if we're looking at 1, 5 and that's got the number that we need, these two will just swap. And so now 1, 3 matches 0, 0. And just like 1, 3 matches 0, 0, 2, 4 will match once it runs through its check, because it'll swap with whichever one is holding the number that matches this 1, 0. That's this 0, 1. And all we do is send different values to check the front. We send that +1 because the x plus 1 is 2, and so that 2 side is going to check, that 2 is going to be the number it's checking against, and that 2 plus 1 is 3, and so it's checking against game piece 3. And so all we do is we send all the values that we need to check all the certain sides. It's going to use the same type of mod system in case anything goes above 6, and if it doesn't, well, at least it's there for the next check. And then it swaps the pieces depending on which side is holding the number that needs to be matching, and that's it. So after we have checked all of the sides, the center front, center back checks, and switched them all out, we then go to our bool, which is our does board match. And so what the bool does, it says, let's check game piece 1 through 6 and make sure that let's make sure that it's equal to 0, 0. So we give integer I the value of x plus 2, which we have determined is the thing we need for our center check, and we'll mod that. Since we no longer have our mod set up, we'll just mod it ourselves, and we'll just check and say, does x1 match 0, 0, and if it doesn't, we're going to return false, and if it does, return true. If we return true, we then jump out of our do while and we will display our function. If it doesn't, we have been swapping three values back and forth, and it is not going to be solvable because for some reason maybe the 4 and the 3, these numbers match and so does this number, and so all these are going to do is pass around the same number every time we check, and so we'll just need to reshuffle them all and have it run a whole new randomly shuffled numbers. And so we'd jump back up to the top of the do, and we'd shuffle again, and then check and see if the board matches. If it does, then we will jump out of puzzle, and we'll have nothing else to run, and we will run our display. I originally, in display, printed out hex colon and then the numbers that correspond with each game piece, and it was hard to read and hard to see where my errors were in the code, and so I eventually made this with the help of this photo by just printing line by line whichever game piece indexes correspond with the different numbers, because that's what these numbers are, just the index values. So what I did in the code is I just printed out each line hex 10, and that's that top number, and then the next line I did hex 15 next to hex 11, and then the next line I had a 60, that the 1 that's in the middle hex value, so it would be in between these two, and then the 20, and so on and so on. And so I did this actually probably halfway into writing this whole program, and it helped me figure out kind of where my problems were in the different logic for the different checks. I would have two numbers next to each other that were supposed to be the same, and they weren't matching, or duplicates or whatever, and it's a lot easier if you make a solution that you can really see where your problems are, or where things are running correctly, so you don't have to mess with those. But definitely using visuals is a big part of doing these kind of projects. It really helped me finally finish this project. But thank you for watching, and I hope to make some more videos in the future.